Howdy folks, welcome back. So in this video, I'm just going to quick go through the practice quiz and again show you how I go about solving the problems. Again, I recognize this by no means the only way, and in some cases it might not be the way that makes the most sense to you. So if you have a way that works for you, as long as you end up with the correct answer at the end, you don't necessarily have to do it the exact way I did it here. But if you're not quite sure where to start, hopefully you'll find this video helpful here. All right. So again, as I mentioned in class, the first question we'll be dealing with solving an exponential equation. So here we have the exponential equation 9 to the x plus 1 equals 27 to 2x minus 1. All right. So again, an exponential equation, by definition, is an equation where you have your variable in the exponent there. All right, so again, your first step is to determine whether you can write both sides in terms of the same base, because if you do that, generally that makes it a lot easier there. In this case, 9 is 3 squared and 27 is 3 to the third. So yeah, so we can write both sides in terms of the same base here. All right, so we have 9 to the x plus 1 is going to be 3 squared to the x plus 1, and 27 to the 2x minus 1 is going to be 3 to the third to the 2x minus 1. All right. Again, as long as you have both sides in terms of the same base, which again, the base is whatever you're raising to the power of the exponent there. All right. So again, one of the rules for exponents is if you have an exponential expression that you raise to a power, you can combine that into a single exponential expression there, and then you multiply the two powers there. So that's what you're going to do here. So again, when we multiply, we have to remember that we're distributing our exponent through to each of my terms. So a lot of times where people tend to make a mistake here is they take the 2x, but then they forget to distribute that 2 also to the plus 1 there. All right, so when we do that, we end up with 2x plus 2. And here we can do a similar thing, so we can distribute the 3. So that equals 3. So 3 times 2x is going to be 6x minus 3. All right. And once you have both sides written in terms of the same base, you can just set the exponents equal to one another. All right. So to solve this for x, you can just set 2x plus 2 equal to 6x minus 3. All right. And now we just have a linear equation that we need to solve. So to solve this, we can just get everything involving my variable x on one side. So we can subtract 2x from each side, add a 3 to each side to get everything that doesn't have an x over on the other side. So that's going to cancel here. Those are going to cancel. So 2 plus 3, so that's going to be 5. And then 6x minus 2x is going to be 4x on there. And again, once you have everything involving your variable on one side, everything else over on the other side, you just divide both sides by your coefficient or the number in front of your variable. All right, so you have x equals 5 over 4. So yeah, so on the quiz, you'll be able to rewrite both sides in terms of the same base. So that's how I go about doing it. Another way in which you could do it is you could take the logarithm of both sides, and if you can't rewrite both sides in terms of the same base, that's how you would solve it, is you would take the logarithm of both sides and bring the exponent out front, and then kind of follow the steps through there. And if you do it that way, you'll end up with the same answer at the end. Either way, this way just is a little bit nicer, especially when you have algebraic expressions as your exponents, as opposed to just single term expressions. All right. Next question here is dealing with properties of logarithms. All right, so the main properties that you need to know for the quiz is the product property. So if you have the log of x plus the log of y, that's going to be the log of x times y. So when you have the sum of two logarithms, you can combine them into a single logarithm, and then you're going to take the product of each of those. All right. Next property is the quotient property. So if you have the log of x minus the log of y, that's going to be the log of x divided by y. So if you're subtracting two logarithmic expressions, you can combine it into a single logarithm, and then you're going to take the quotient of your two arguments. And the last one here is if you have r times the log of x, you can bring that exponent into the logarithm. So you have log of the x of x to the r. All right, and those are probably the three main properties that you need to know for the quiz here. All right, so yeah, so we're just going to take this kind of step by step. So the first step here, so again, just kind of following the order of operations. So the order of operations, so I'm multiplying here first, so I'm going to simplify this first term. All right, and to do that, I'm going to use this product or power property. So I can simplify that first term as log base 3 of a, and then I'm going to take whatever I'm multiplying out front, and I'm just going to write that as the exponent of my argument. So I have log base 3 of b plus log base 3 of c. All right, and the last operations are addition and subtraction, so working my way from left to right here. So you have the log base 3 of a to the third minus the log base 3 of b. So I can use the quotient property here. So I can rewrite this as log base 3 of a to the third divided by b plus log base 3 of c. And then finally, to get it into a single logarithm, we can use the product property here. So since we're adding two logarithms together that have the same base, we can combine those into a single logarithm, and we can just take the product of my two arguments. So the product is going to be a to the third times c, all divided by b. All right. And the last question here is dealing with solving a logarithmic equation. So here I have log base 5 of x plus 2 plus log base 5 of x minus 2 equals 1. All right, so my first step in solving a logarithmic equation is to combine it so I have a single logarithmic expression, or at most one logarithm on each side. So yeah, so again, I can use the product property here to combine these two logarithms into a single logarithm here. So we have x plus 2 times x minus 2. That's equal to 1. Getting ahead of myself. All right, so once you have it, so you have a single logarithm, or at most one logarithm on each side, what you're going to do is you're just going to convert it to an exponential. So again, to do that, if you have log base b of x equals y, that's equivalent to saying that b to the y equals x. Again, you're going to take your base, you're going to raise it to whatever your logarithm equals, and then you're going to set that equal to the argument inside there. All right, so here in this case, so my base is 5, so I have 5 to the first equals x plus 2 times x minus 2. All right, so 5 to the first is just going to be 5. X plus 2 times x minus 2, so that's going to be x squared minus 2x plus 2x, so those are going to cancel. And then we have minus 4. All right, so then to solve this, I'm just going to add 4 to each side to get it so I have my x by itself, because then I can use the square root property here. So I have 9 equals x squared. All right, and then to solve it, you can just take the square root of both sides there. All right, and again, square root property says that when I take the square root, I have to account for the plus or minus. So square root of 9 is going to be 3, so my answers to x squared minus 4 equals 5 are x equals plus or minus 3. All right, now it's important here to go back and make sure that your answers are in the domain of your original expression. So again, the rules that we have for domain is we can't divide by 0, we can't take the square root of a negative number, and we also can't have the logarithm of a negative number. So if x equals positive 3, Both of my arguments for my logarithms are going to be positive, so that's fine. That's good. That's what we want. However, if x is negative 3, then it turns out that both of my arguments for my logarithms are going to be negative, which you can't have. So you can just kind of ignore that negative one. So my final answer is just going to be x equals 3. All right. So again, that's how I would go about solving the problems. Again, I recognize it's by no means the only way. So if you have a way that makes more sense to you, again, as long as you end up with the correct answer at the end, I'm fine with you doing it that way. But again, if you're curious as to where I would start, that's kind of how I go about solving those. So hopefully you found that helpful. Have a lovely day, and I'll talk to you all later. Bye now.